Welcome to the Silicon Learners. Today's topic is what is the types we can write FSM. The main three types: one process, two process, and three process. First of all, we have to understand that why these processes are made in the Verilog. So let us go. So this is the three FSM coding style: one process, two process, and three process. Okay. So let us understand what is the actual problem. The problem is the messy FSM RTL code. The FSM when works perfectly, simulation passes, synthesis passes, FPGA runs correctly, but many ASIC engineers would reject this code in review. The question arises, why? So in the hardware design, alone code works is not enough. Your RTL is must debuggable and maintainable. So this is the main reason why this different FSM coding style needs. Okay, so let's move ahead. This is the evolution of simple to complex ASICs. Okay, in early days FSM is required only for traffic light controllers, vending machines, simple common logic, and these are all common and small of FSM. So not much need this type of processes. But when then chips grew, the CAD system added, memory controllers added, and the problem arises about debugging. Output mixed with transitions, use case statement, waveform confusing, and code review difficult. So this is the solves with these FSM coding styles. Okay. So every FSM has three core responsibilities. First, store the current state. Second, decide the next state. And third, generate the outputs. Okay. The current state stored by state register or flip-flops. It holds the present states and updated it on the next clock edge. The next state decider. It is a combinational block. It computes next state based on current state plus inputs, and the output block, which is generate output, is a pure combinational logic block. It produces outputs based on state if it is Moore machine, and based on state plus output if it is a Mealy machine. There is three types of FSM. Okay, before it we understand the need of these processes. So see this code. This code is 100% workable and compile. I can show you. Okay. So see this. This code is 100% workable. But what is the problem with this code? In this code, this is a simple motor code. When the motor turns on, alarm level and sensor level it is defined. Okay. So the first problem is hidden latency. See this, our motor logic is depends on clock. It is not a combinational block. Means it is a motor will be turned on after the next clock edge, not a instantly like a combinational block. So ideally we want motor as a combinational logic, but in the Verilog code we define in the always block with the positive edge of clock sensitivity list. The next another problem 2 is logic bloat. It is a mixing match with state transition. Okay, so this problem arises in synthesis level. Our simulation good, it is all 100% correct, but at the synthesis level it problem arises. The another problem is missing default. See this, here in the case we not define what will be output at the default. So this is a problem 3. If the state accidentally hits 3D2, means case 2, the output will be latch. We are seeing the previous videos how the latch behavior arise. Okay, so this is all the problem in the one messy FSM codes, and this is why the different processes needs. So we will study what is that processes. Here is the type of one FSM writing processes. It is one process FSM. So what happens inside this? Inside the one process FSM, states update, next state logic and output generation all together in the one block. These processes are defined when the small FSM needs like a vending machine, traffic light controller, etc. The benefits of this one process FSM are compact and short code, good for small FSM and beginner friendly, common in FPGA development. But what is some problems also it has? When the states are many much like 20 state, 50 transitions and many outputs, one block becomes giant wall of RTL and output logic mixed with the transition. So here it is a example of the first process of the FSM. You can see here only two states and one output, and we can define all this in the one always block and one if else block, so not much problem arises. Next, another type of the process is two process FSM, where the process 1 two process FSM contains two process. It is a separating between sequential and combinational logic, means output and the about when the output should evaluate, means state update. It is a controlled by sequential logic. So this is the first process where the sequential logic will be arise. It is store the current state register, update on clock edge, and it is contain non-blocking assignments, where for the output logic there is a combinational logic. It is decide next state logic and generates output. It is use blocking assignment. The two process FSM writing style makes easy to mirror real hardware, easier waveform debugging and faster RTL bug resolution. So that's why it is preferred by many ASIC teams in the industry. Okay. This is shows why ASIC teams prefer two process FSM. The main reason is easy debuggability. Another reason is RTL bug resolution, and another reason is cost of bugs. One RTL bugs after the layout tapeout can cost huge money. Debugging time is expensive in ASIC design, so prevention is better than cure. In ASIC design, debugging time is expensive. One RTL bug after tapeout can cost huge money. So that's why ASIC teams prefer two process FSM. So here is the example of two process FSM, where we separate the output logic and state transition logic different. Here is the sequential block. As we discussed, there is a two process writing style. One is sequential logic, which is main cause for the state updates, and another is process 2, where we declare our combinational logic. So this is the cause of when the output 1 is arise. Okay. But there is some more complex logics or more complex FSM, so we need three process FSM. So three process FSM is good for the large and complex designs. It has three process. First contains state register block, second contains next state logic block, and third block contains output logic block. In the state register block, our sequential logic. In the next state logic block is our combinational block, and our output logic block also a combinational block. The task of the sequential logic is the store current state, flip-flop updates. We use non-blocking assignment in this block. It has mainly control the state transition. Okay. The next state logic block, it is a combinational block. It decides next state transition table. It is used blocking assignments. It depends on input plus current state, and the output logic blocks is generate outputs. It depends on Murray and Millie style. it is used blocking assignment and defines clean separation. Here is benefits of the 3 process FSM. So the maximum organization, clear responsibility per block, easy to modify one part, best for large complex FSM. It is easy to debuggable because in complex design debugging is harder part. In when we use 3 process FSM, all blocks are already different. But here is some loss in 3 process FSM. Here it is more code of lines, more verbosity, more structure overhead, and can be overkill for small FSM. So for small FSM we have to use 1 process FSM, and for the more large and complex design we can go for 2 process FSM and 3 process FSM. So here is the example code of the 3 process FSM. So here we can see the process 1, which is sequential block, where we defines our state transition when the state will be next state. Okay, the process 2, it is our combinational block, which is decide state transition when the next state will be arise. Okay, and the third last block is our output logic combinational block. So it is defines when the output will be 1 and when the output will be 0, at which state output will be 1 and which state output will be 0. So why, this is the reasons why the all 3 processes matters. Here is a comparison tables of why which FSM style is best and when which style you have to use. Okay, you can read it. The key takeaways, the real lessons. FSM coding style were not invented because textbook wants more chapters, but it is invented because some issues with the older style like debugging pain, scaling issue, team collaboration and maintainability. With in the complex design with using 3 process FSM we can solve all these issues. Thank you so much. FSM, this is all about FSM coding style in ASIC design. Okay, understanding why, not just what. In the next video we will look over the Millian-Murray, how Millian-Murray can glitch on the FPGA. So thank you.